In this video, I will discuss a circuit analysis method which is called node voltage analysis or nodal analysis. So, the I will start with an arbitrary circuit. Just arbitrarily drawing a. So let's call this one. Now, when we analyze this circuit, let's call this I1, I2, and then R1, R2, R3, R4. So we don't know anything about we know these current values and the resistance values, but when we analyze the circuit, our purpose is to know the voltages at all of the nodes and the current through all of the branches. So these are the branches and there are nodes. So node is like this one. I will draw the nodes there. So this is one node, there is one node here, this is one node, this is one node, and there is another node. So knowing we need to know the voltages at all of these nodes and also current through each all of the branches. Now node voltage method is the procedure is first we assign arbitrary voltages to all of the nodes. So this one let's call, and so I first we analyze, first we see how many nodes are there. So we can see there are 4 nodes in this circuit, and we will assume one node to be the reference node or ground rather, and it's convenient to assign the node where most of the branches are connected as ground node because that will make the analysis convenient. So here we can see here the most number of branches are connected, so this one let's call this ground node, and once we do that ground this voltage is 0, so this becomes the reference node. Now we will have the voltages of all other nodes as the voltages will be uh, with respect to this node, because that's the meaning of voltage at any node. It has to be uh, with the reference to the ground. So let's call this one node 1. So this is, let's call this voltage V1. So it's just arbitrarily assigning the voltages, V2 and V3. Now once we have done it, we see there are 3 nodes and there are 3 unknowns in this one. So we will write the Kirchhoff's current law in all of the nodes. Each one we will write Kirchhoff's current law. So this one, if we write in this one the Kirchhoff's current law, we can see this I1 is an entering current, and this current we don't know, but we know the voltages. We, by know I mean we have assigned voltages. So what we can do, we can write the currents as like sum of the leaving currents or whatever in the left hand side, and then on the right hand side we can write sum of the entering currents, but it's just arbitrary, whatever we do it's fine. But usually we write in terms of leaving currents because that way this voltage is the, so if I write this current as a leaving current, then it will be V1 minus V2 over R1. So the current is going away from the node. So this is how normally it's written. So this is this current, and the other current at this node is the entering current. So let's write it on the right hand side. Let's call it I1. We know that's I1. So this is one equation, equation 1 let's call. Then we now write KCL for node 2. This one was for case node 1, so node 1 there. Then we write for node 2. Once we write for node 2, we will again write in terms of leaving current. So now this current will be like this, V2 minus V1 over R1, that's this current, and then the current this way will be V2 minus V3 plus V2 minus V3 over that's R3, and finally this current which is going away, that's V2 over R2 because the other node is ground, so V2 minus 0 or just V2 over R2, and then that's the 0 there. So this is the second equation, and the third one is for the third node, and we see for third node we have this node there, so it goes the current, this one is going away, so that's I2. We can write it on the left hand side, I2, because it's going away from the node. Then this current will be V3 over R4 plus V3 over R4, because the other side is ground, plus finally V3 minus V2, because this current is going that way, has to be away, as I said. It's just what we the way we write the equation. I am just assuming it this way, but later we will see this is a slight benefit if we write it like that. The equation gets a pattern, but let's just see it this way. So this is R over R3, so that's there 0, and that's equation 3. So this is 2, this is 3. So I will finish the video here. This is just part 1. I don't want to make the video very long. So here I just have written the equation, but later I will arrange, in the second one I will arrange the equation, and I will write a form so that the equation can be solved in a form. So yeah, this video ends here. This is just part 1. I will do the part 2 sometime later.